Hello everyone, Wave Optics Part 2 Interference. In this video, I will be talking about interference of light. First, we shall discuss the concept of coherent and incoherent addition of waves. So, in this section, first we shall see what we mean by the superposition principle. That is, according to superposition principle, at a particular point in the medium, the resultant displacement produced by a number of waves is the vector sum of the displacements produced by each of the waves. Now, coherent sources are those sources which emit waves that have same frequency and zero or constant phase difference. Now, we can consider a case as shown in figure A, in which two needles are used to produce waves at points S1 and S2. Now we can consider a point P such that S1P is equal to S2P, or the waves reaching the point P from S1 and S2 is same. That is, they are in the same phase. So the resultant displacement at P is given by Y, which is the sum of the displacements from S1 and S2, that is Y1 plus Y2. Since they are equal, we can write it as 2a cos omega t. Now the intensity of the wave is proportional to the square of the amplitude. Therefore, in this case, the intensity is proportional to 2a the whole square, which is equal to 4a square. Now we can consider a case in which a point Q is taken such that there is a difference of 2 lambda between the waves reaching that point. In that case, the displacement at S1 Y1 is equal to A cos omega t, and by the second source S2, that is Y2 is equal to A cos omega t minus 4 pi, which becomes A cos omega t. In this case also, the two waves are in phase with each other, and hence they add up and constructive interference takes place. Now we can consider a case in which the displacement is a multiple of negative 2.5 lambda. In this case, the equation of the first wave, that is from S1, is equal to A cos omega t, and from the second source Y2 is equal to A cos omega t plus 5 pi, which becomes equal to negative A cos omega t. Now in this case, the resultant at R is 0. Hence, in this case, destructive interference takes place. Now, from these two instances, we can summarize and write the expressions as: if the difference between S1P and S2P is equal to n lambda, then constructive interference takes place. And if the difference between S1P and S2P is equal to n plus 1 by 2 lambda, that is an odd multiple, then destructive interference takes place. Now, if the two sources are coherent, that is, if the two needles are going up and down regularly, then the phase difference at any point will not change with time, and we will have a stable interference pattern. That is, the positions of maxima and minima will not change with time. However, if the two needles do not maintain a constant phase difference, then the interference pattern will also change with time, and if the phase difference changes very rapidly with time, the positions of maxima and minima will also vary rapidly with time, and we will see a time average intensity distribution. Now we are ready to discuss about interference of light waves and the Young's experiment. Young conducted an experiment using a coherent source. The figure shows how he obtained a coherent source. That is, he used two screens. In one screen, there was a small pinhole, and it was illuminated by a bright light source. And in the second screen, there was two pinholes. And these two pinholes were used for producing the interference pattern. Now the figure B shows the two sources, coherent sources S1 and S2, which are separated by a vertical distance small d, and they are at a distance of capital D from the screen. Now at point P, which is located at a distance x from the center O, now the path displacement, that is S2p minus S1p, is equal to n lambda. That is the case for constructive interference. We can take S2p the whole square minus S1p the whole square, and using Pythagoras theorem, it gets simplified and the value is equal to 2xd. Therefore, S2p minus S1p is equal to 2xd by S2p plus S1p. Now, if d, which is the separation between the two sources, is very small when compared to the screen distance, we can write S2p plus S1p is equal to 2 times the screen distance. Therefore, x is equal to n lambda d by d, which is the case for constructive interference. Now, in the case of destructive interference, that is S2p minus S1p is equal to n plus 1 by 2 into lambda. We get x, which is the displacement, is equal to n plus 1 by 2 into lambda d by small d. The interference pattern consists of fringes. The maxima are bright while the minima are dark. And the fringe width beta is given by xn plus 1 minus xn, which is equal to lambda capital D by small d. Now this figure shows the fringe pattern obtained. The default fringe pattern obtained is hyperbolic, and the intensity is maximum at the center. If the value of D is increased, the width of the fringe decreases and the fringe pattern becomes almost straight lines. Now this graph shows the intensity and the path difference. Now if the light source is shifted up as shown in the second figure, the central fringe is shifted downwards. Similarly, if the light source is shifted downward, the central fringe will be shifted upward. The intensity can be increased by replacing the point source by slits. So this is the end of this video. In this video, I have mainly discussed the concept of interference. If you have got any doubt, please comment in the section below. Thank you.